Let's start off by taking baby steps. We're going to talk about distance vector first because obviously we're dealing first with smaller networks. We'll then expand from there. When deciding on using distance vector protocols for a given network, we need to first think about the issues that we may face. Probably first and foremost is the issue with distance vector routing loops. And this goes back to the concept of what the characteristic of distance vector really is. Remember, a distance vector routing protocol advertises via broadcast its entire route table out of every interface at a predetermined interval. What this means is that every router that exists within a network environment that's running distance vector is going to tell every router about everything it knows, whether it originated locally or if it was learned from another router. It exchanges the data in the same way no matter what. This is called a routing by rumor process, and it can actually generate routing loops if we're not careful. Now, distance vector routing protocols have been out for a very long time, and there have been processes put in place that are designed to eliminate the routing protocol loop. Let me show you an example of a routing protocol loop here based upon the normal characteristics of distance vector. In this situation, what we have is a set of 5 routers: Los Angeles, Phoenix, San Jose, Dallas, and Fort Worth. Los Angeles, Phoenix, and San Jose are somewhat redundant, as they do have the capability of sending data directly to each other. We have a wide area connection between San Jose and Dallas. In the local Texas facility, you can see that Dallas and Fort Worth are separate routers. Well, when we look at what a distance vector routing protocol is going to do, every one of these routers is going to generate information about its local routes, and it's going to send it to all of its neighbors in a broadcast fashion. And that means Los Angeles and Phoenix and San Jose will send each other information about everything they know, including information that they have learned from other routers. Fort Worth is going to send information about its own networks to Dallas. Dallas would take that information in conjunction with its own and send it on to San Jose, as if it originated the data. So when San Jose gets the information from Dallas, it doesn't know that it is not coming directly from Dallas. It may assume that the routes that were learned via Fort Worth are really Dallas's routes. It has no way of differentiating between the two. Well, this is called the routing by rumor process. Let me show you now where this can cause a problem.